The order of variables matter in a struct? What? Let's explore. We have these two structs with two boolean and one int64. Let's run this test. For some reason, the first struct is 24 bytes and the second is 16. But look, they are basically the same. They store the same data inside. But actually, there is a hidden layer. Golang is adding more bytes to these structs to make our CPU happy. Why it's required? Let's explore this situation. Imagine we have a CPU and this CPU is hardwired to read 8 bytes at a time. If Golang will not add additional byte to the memory, the CPU will have to work a lot more to read 8 bytes of data. Let's make it more clear. A boolean is 1 byte, like this. A int64 is 8 byte. A boolean, again, is 1 byte. In this situation, what does Golang do? It adds here 7 byte. Okay? And after this, it adds 7 byte. When our CPU comes to read this boolean, it will not read only 1 byte, but will read 8 bytes. And this is making CPU run faster. Because, you see, the CPU is coming here, it grabbing 8 bytes, so it doesn't have to do jumps around, and reads this boolean and go on. But if we does not add this 7 byte of data, what will be happening? Imagine this is our 8 bytes. If we have only 1 byte at the start, like this, like call it B, okay? After that, we have to add like our int64, okay? But the int64 is 8 bytes, so here we have only 7 bytes. We would have to put like a remaining part of this int in another box, like here. So what the CPU will have to do? It will have to like come here, understand that this is an int64, but I need to grab more bytes to make it whole. So from here, jump to another location and then combine, so merge them to make a real int64. If we do not have this padding, in a lot of cases, we will have to use 3 CPU cycles to do 1 little read. So doing this padding, it's just made to squeeze full performance from our CPU. But there is a catch. If I go and run a benchmark, what do we have here? In this benchmark, we simply like loop over some amount of items. As you can see, like this is the amount of times it was able to run. The bad aligned struct ran 600 times. The good aligned one ran on my machine 1200 times, and the speed for operation is basically double. Why this is still happening? If this padding, this adding of memory was supposed to be this magical pill to make our CPU happy and our life easier, the fact that the CPU has cache, and if we are able to pack our structs, so our data, in the cache of the CPU, and the CPU is able to grab from that cache that 8 bytes, it will be working in a much faster way. And actually, here, what is happening? This struct has exactly 16 bytes, and this is 24, you know? On my machine, I have 64 byte cache line. It's like the cache of my CPU. So we can fit 4 good aligned structs to my cache line. And In this case, with 24 bytes for struct, only 2 of them can be fed to the cache line. So this is you can call it an optimized version of a struct. It's running so much faster just because we know how to correctly place our variables.